So, hello everybody. Thank you for joining this session of San Francisco Computational Design Institute. SFCDI is a non-profit organization whose goal is to spread knowledge about computational design and innovation design technologies. Today's meeting hosts 4 guests from 2 different companies. They will talk about some exciting news, some exciting novelty technologies related to the design, including AR, VR, and parametric designing. But I will leave the word for Jennifer for a few announcements.
Hi, great. Up on the screen, you can also check our blog, our email, and our Twitter for any of our updates. We have a couple of announcements. Our next SFCDI event will be on July 17th, Friday at noon. And we also want to announce our logo competition. We're hoping to revamp our logo. And the first person who wins the prize will receive a $500 Visa gift card by Autodesk. You can find out more information on sfcdi.org logo competition, and our deadline for that will be August 12th, 2020. We'll be excited to see what people come up with and who wins that prize. Our next event on July, we'll have 2 speakers. We'll have Matthew Gilbert presenting layout optimization of building structures, and we'll have Emily Ullman talking about spatial first. We have a few sponsors that we'd like to thank today. We want to thank Autodesk, Gensler, and Lowney Architecture. And I'll let Gabrielle go.
Thank you, Jennifer. Today, as anticipated, we got 2 special guests. We have Satoru Sugihara from ATLV, presenting engineering, scientific, imaging, computational design. And we also have David Alpert, Mike Hoppe, and Mac from Geo Pogo presenting 3D remote collaboration, reducing costs with a client-friendly solution. I think the first guest speaking is Satoru Sugihara. After each presentation, there will be a short Q&A session. And then we'll, at the end of the meeting, we'll have an open session for more questions. So without further ado, I would like to give Satoru the presenter role. All right, Satoru, you should be presenter now. So please, you can start your presentation.
Sure. Hello, my name is Satoru Sugihara. I really appreciate this opportunity to present today. So today I'm gonna talk mostly about my computational design work and talking detail and techniques on each. But just to start, I categorize computational design into 3 types. And then, so I thought this is just for kind of clarification in the organization, but like I thought there's a 3 types. One is the design engineering, and second data-driven design, and that's imaginative design. And then each of them is like the design engineering, like for example, optimization of design. And for certain type of efficiency or performance, and another type would be in this category is a rationalization to make it more, make geometry rational, or the kind of certain geometry fitting for certain type of construction. And second type, I call it data-driven design, which, for example, is like you drive design by certain data, like a solar data, or making certain rule responding to environment, or even like you have certain circulation simulation or analysis, and then you have rule to draw or generate design out of it. And the third one is imaginative. This just comes from any idea out of your imagination. And you just, for example, if you sort of like using Fibonacci sequence to drive your design, and they just try to figure out how to use that as a 3D geometry or certain type of design, and you make the code or parameter to realize that design. Or if you imagine like all the drone or robots kind of assembled to build your house, and then you simulate, or you set up certain agent rule or something, and then try to simulate and design how to generate the actual final design instance. So out of those three, actually there's a, so that the design engineering is more like you have design first already, and you optimize it, rationalize it, so you re-engineer the design. But data-driven design, imaginative design, your idea or your computation comes first, and the computation generates the design. And then the characteristics of each is corresponding to like a design engineering, like engineering approach, and then but the data-driven one is more scientific approach, and imaginative design more artistic or sometimes culture approach. So that's a different type of way of thinking in computational design. Also, in actual project, one computational design approach or technique involves each aspect, or sometimes it's all mixed together. So it's usually, it's not just one of them. So that's the reality. But anyway, so just keep in mind that there's those three aspects. And then now I want to show you project example. And then I didn't really introduce myself, but I used to be a computational designer at Morphosis Architect in Los Angeles, and I took care of a facade for 5 years. And after that, I started my own firm as a kind of computational design consultant to help other architects to design complex facade. But anyway, first project I want to show you is Morphosis, the theater project in Paris. And that was the first project I worked on as a computational designer in Morphosis. And then that was a skyscraper in Paris. And then we won competition in 2006, and then the project started 2007. But I mean, it went to the phase. Actually, they dug a hole in the site, but the Lehman shock killed the project, so it didn't happen. But so I worked on 3 different areas in this project. I generated, or I optimized the diagram structure, and also rationalized grading planes, and then I designed the solar shading scheme outside of grading. And then first about the scheme, that was it was made out of a stainless steel mesh to function as a solar shading panel. And then, but the first kind of phase is like just study tons of ideas. So in the beginning, just a different type of panelization algorithm applied, and then just to study, check which would fit best with the building in terms of concept and visual and other aspects. After kind of narrowing down the option and start patterning, and then just testing bunch of kind of patterns to make the building more dynamic in terms of appearance, and also certain variation of performance. But and by the way, I mostly use processing as my design platform. So I just write a bunch of code, and then those kind of patterning or like a size of panel are kind of each different parameter, but I can kind of layer each like function or some kind of chunk of code can stack together, so I can change and or swap anytime to test tons of options. For example, there's I'm showing 12 different options of the scheme studies, and then so changing size, changing density, bringing randomness, bringing certain gradient, etc. So those are just by changing the parameter and just swapping the layer of the code. The other aspect of its scientific part is that is for solar performance optimization. And then in this case, we chose a diagonal panel as a skin design, but I didn't really decide like what orientation panel should be located. I mean, the diagonal axis is kind of following the base building geometry, but axis, rotation around the axis is defined by panel itself, meaning the I wrote code for each. Actually, each panel acts as the agent, and they try to figure out where the sun's coming at the highest point in front of the panel. So each panel searches the sun coming in front, and then calculate the highest sun, which is actually always the summer solstice, and then try to maximize the cast shadow area, which is actually you can just calculate by one vector calculation. As a result, so each panel is optimized for different time. And then I'm showing the diagram, and then so each like a south face of the building is optimized for noon, and then east side is for morning, and west side is afternoon. So each of them is slightly different time. And the next part is the structure. So diagrid structure is, I hope you are seeing the animation somewhat smoothly, but building diagrid is simple if you have 4 edges geometry, but if your edge is irregular, the diagrid boundary condition irregular. To solve that, I use just mesh relaxation method using the tension on the particle. And then next part is the rationalization part. If I make the diagrid smoothest, that means that it's most expensive because each length of column is slightly different. To solve the issue, I just try to repeat same length or same angle or same size of a triangle or to cover whole building. And that part, finding the area is just coming from geometric knowledge manually. But I use processing code to stitch them together. So if you lose the color, I mean, each color represents the same area, but you don't really see the theme. So that's how the rationalization process went through. And another part for rationalization was grading. And initially, we were thinking just having same logic with diagrid, just projecting diagrid onto grading surface and then flatten or triangulate those panels. But the problem was that this creates tons of small, sharp triangle, which is impossible to produce as a grading panel, which has to be filled with just metal panel or something. So at one point, I just had a different approach and then decided went through the radial faceting. It's actually slightly, it's shifted. Actually, it's not even cylinder, it's a cone. But so in that way, at least I can remove most of the triangle and then most of the rectangle or parallelogram or trapezoid. And then I also made a kind of visualization of the exploded panel and then count them and how many they are. And then I'm showing the diagram now, but so this diagram, so when I was going through, just checking tons of options and then just checking. So this is automatically generated by processing to illustrated file, so just can check how many are there, it's rational or not. So then that's a final design. It should be shown soon. Yeah. Then next project. So next project I'm showing is the Milan Expo China Pavilion project. It's designed by Studio Linkwork, based in New York. And I took care of the roof facade panels and that's made out of a woven bamboo panel mounted on metal frame. And I worked on this project since the competition phase. So in the competition, we just granting through production, so the geometry wasn't clean. So first thing I had to do after winning a competition was I have to clean up all the geometry, then rationalize them. And rationalizing them mean mostly just to maximum number of straight line and then flat plane, and then if it's curve, approximate to arc for better panel building later. And then next step was to build up grid as consistent as possible. And then on that grid, I built a kind of perfect panel, meaning the zero tolerance and all kind of no gap. But that creates a maximum variation of a panel. So next step is to unitize them. And then in this case, so each panel in this building was this roof was slightly bent, maximum 4 lines. So I limited the number of folding, 0 or 1 or actually maximum 2. And then also lifted the panel. Actually, that was just design decision with the architect. And then plus that gives more room not to collide. But anyway, so at the end, the unitization kind of absorbs certain slight deviation into same panel size, and then it can limit the variation of a panel. Also, toward the end, there stands up unique panel. And then another aspect I had to consider was the joint variations. And then so so this was a unitization of joint. But joint, if I made the joints very solid and then less tolerant, that means it's difficult, or that creates some variation of many variation of joints. So we had certain universal joint which can absorb certain angle or distance from the joint location. Although the height was fixed, so offset from the roof line was fixed, so I tried to unitize them. But the problem was that if you unitize the joint, that destroys certain unitization of the panel, so it's trade-off relationship. So we had to just find the best balance in terms of cost and visual and etc. And then with all other contractors and then joint makers or other facade engineers. So to do that, I gave control of my script to the architect to change things quickly. So I externalized my parametric data in Excel sheet, and I gave my code, so my code can read their edited Excel sheet to quickly change certain areas. So, but anyway, so they decided that balance of trade-off. Then the roof was built successfully. You kind of see I mean, it's smooth, but you kind of also see the gap if you try to see it. So that's the area unit can changes to next unit. And now I move on to the next project, which is a small house project in Singapore. Architect is Wow Architects. And in this house, the second floor and third floor are all covered by the perforated panel. And it's actually tabbed perforated panel. So the punched out piece is actually hanging RBB. So, but architects came with the idea they wanted to project certain tree image. So I started with some algorithmic way of generating tree, but I had to work. Actually, once we talked to the fabricator, they have more severe constraints of like how to produce perforated metal. It's made out of a die or combination of die, so you can use just limited number of size of holes and then location. So first they came up with module, and I use module to create a branch image. Although the final tree image is super simple, but on top of that tree image, we control the perforation for privacy, and then the pushed out tab function as a kind of a louver to cut solar light as well. So I control that to maximize solar performance as well. So I created tons of bitmap to control like a whole size, the whole amount of tab pushed out, and the angle, orientation, etc. On top of the branch image. And then I put everything, all the information into processing, and that just generate whole 3D geometry and also 2D drawing at once. And then that was converted to DWG drawing at once, and then generated a 180 drawings, and then just sent to the fabricator with the die number. Then the house was built. Then next project, going back to Morphosis project, and then I worked on Emerson College Los Angeles Center in Hollywood, and I worked on the courtyard facade specifically. And then that was the courtyard facade is the panels are made out of folded aluminum panel. And this building is actually dormitory building, so students live there. So it's private area, although the building in front of the plus courtyard is public area. And then this is art school, Emerson College. So I tried to create a dynamic screen for, but still kind of create privacy loosely. And the first idea of this design was like just having certain simple element and then slightly tweak and put them all over to create certain like a field like smooth effect. And then I went to a bunch of options and having idea about folding geometry. And then I actually, so that was the first phase of the design studies, and then second phase, actually later I changed the logic of design by using certain optimization, or actually soft solver. There's a certain constraint about the layout of panel, and which is first is simply no collision, second maximum density of differentiation, third we want to have the pattern reflecting certain other building or other environment. And then constraints for I want to have experience of people walking on the corridor, having like an opening and close at least once, or hopefully twice. And then the fifth constraint was a severe one, that legally it's required to open 50%. So that was another constraint. To solve all of them, I use a particular estimation as a soft solver. So it's best effort, so not necessarily solving whole thing, but just adjusting particle and force, and then try tons of actually studies, and then that shows the so we found the final design instance which can satisfy all the constraints. Then, but there's one more aspect in the project. The number of panel on one side is like 1,500. So total, so these are both sides. So 3,000 panels there, and then it looks smooth, but in reality, it was rationalized or unitized into 15 different panels in 3D. But half of them just flip. So unfolded shape is 8 of them, and then 8 of them are perfectly fitting 8 feet by 4 feet aluminum sheet. So for the minimum cost for water jet cutter to run through. So that was another aspect of the project. And another Morphosis project shows similar technique, and then this is that is a interior design project in New York. Then so that's a ceiling panel design, and but panel logic is same. There's a 6 different unfolded shape, and then folded in 6 different ways. Total creates 36 different panel types. But problem was that the ceiling was not flat, like Emerson College, and even each region not flat. It's twisted, trapezoid, or whatever quadrilateral shape. So question was which panel fit in what orientation, what location? I mean, like slightly adjusted. To solve the issue, I just simply wrote a code to search all of them. All of them mean the all 36 panel and all like a different angle in maybe like 0.1 degree or something, and then slightly different location with 1 millimeter increment. But that doesn't create 1,000 or less than 10,000 options for computer checking all of them is fine. So that could find the best fitting panel automatically. Then next project. Next project is Morphosis, another Morphosis project at Cornell University, Osaka. Gates Hall, that's a computer science department building. But in this case, we knew we go with rational design due to the budget restriction, and then I started with just designing module. But I mostly care about the figure ground relationship. But that's solar shading panel, but I want to make the void part more figural as well. But anyway, going through a bunch of options, and then final one has 10 different panel types to create certain kind of closed condition to open condition. And then it built with certain kind of gradient of opening to close. And then I think I have several more minutes, so I go through a bit quicker. Actually, another project by Morphosis, Casablanca Financial Tower, which is completed very recently, or like half a year or something. And then, but this is same project, starting with module, an LBT module, and then creating, in this case, we wanted with the vertical louver, so, but something fitting with the impression of visual or concept with the building shape, kind of crystal shapes. And so we went solid cement diagonal louver. Then actually, because of the time, I skip some of that. Actually, I just go through slide quickly and not much talking. But this is a Istanbul City Museum, which is currently under construction. And then, but so in this case, we went start with Middle Eastern Arabic idea, but quickly went through more about the kind of grid operation, like what grid fits better with the building shape, and also construction efficiency in terms of where we can put the support for the panel. And then, but so we went through the tons of variation. But it's now under construction right now after certain political turmoil in Turkey. And I think I talk about two more projects quickly. First is interior design projects plus a bit facade. Restaurant building in China, and then architect is Studio Linkwork and Kane AUD. And then that's a Hotpot restaurant, spicy Hotpot restaurant, and the Flagship store in China or Zhengzhou. And then so we or client has certain or request, or we have some idea about more organic shape or sense or design. And then so we went through this leafy shape. And then first that was the kind of idea part or ideation part, but from that I went through all the rationalization and then how to make module out of it, etc. And I'm running animation, though not sure it's running smoothly. But anyway, it generates 10 different modules, and the same idea with the facade.
Satoru, there is a question from Max Nyhaus. He asks, so when generating all these unique panels, do you provide for the dimension of every panel to the client so they can replace them if something breaks?
No, usually that level, like when we know that's unique or too unique, I don't generate that level of detail. And usually these days architects care the rationality what to as a sales point to the client, they want to tell them that's rational. So I would work past them. So at that part, I actually at most interface, not in CD or later phase, interface, I just generate the diagram panel types. Sometimes with dimension, but most of them not with dimensions. And just showing how many different panels there are and how many for each of them, like 100. So panel type 100, second one something, and then but there's like 50 unique those. So that diagram or some diagram I already showed, like color diagram. That is a typical one I show in the like SD and DD. DD phase I might do more, but in SD phase talking to client, yeah, that's the level of the information I generate. Is it good?
Okay, thank you very much.
Then okay, let me continue. So but anyway, so that not leaf, but the organic shape panel idea was implemented, and then there's a certain module on, and then it was produced in this way. The actual materials of this ceiling panel or extruded ceiling panel is actually aluminum, perforated aluminum painted in the warm wooden color. Actually, that color was kind of stuck to the client's mind in the earlier rendering, so we kind of went through it with that. And then I go to the final project. And final project is more a bit research oriented project, although this is an interior design project. But first, I personally at one point interested in the biological cellular growth, why they can grow in that way. I mean, science haven't figured out perfectly yet, but I just started simple algorithm and then building my own. And then, like for example, some simple simulation, it can create organic shape quickly. I'm showing animation, which might be a bit not smooth here, but anyway, so that those kind of color shape, brain shape can be generated easily. So not necessarily that is the point, but I was just explaining what kind of shape can come out of that. So but anyway, once I had the opportunity, actually there was another architect who was also interested in cell growth and who was also researching their own method. And then we collaborated together then we worked on one interior design project, which is in kind of office interior design in China. And I worked with the ORProject, so they are doing their own cellular growth thing, and then we work together. And then so the one shown on the screen is the basically lighting installation. So it's covering light in cafeteria in the office to diffuse in a certain way, but of course creating some sculpture pillars and dynamic atmosphere there. In the fabrication process, we went through structure analysis, optimization, and then the digital fabrication optimization as well. And that was made out of plastic panel, laser cut plastic panel, and then actually joined together and then hung by wire manually. That part wasn't really optimized, but anyway, so that's that. But we try to use that novel method to generate something in reality. So that's the final project, and I just make a summary. So I talked about 3 different type of computational design, and then so those 3 actually out of those 3, the design engineering works really well to create a rational design, and then but for novel design, your ideation, imaginative design works well, but in reality, what we want to do, or ideally, is that in practice, I mean, we need to make it happen, and we have to make it rational. But to move forward in terms of design progress, we need to really think about that as well. So in the research part, so in reality, we need to do both, going back and forth. And of course, it depends on the opportunity. But anyway, so that's something I hope to keep doing to make rational and novel or complex or advanced design altogether. Thank you very much.
Thank you very much, Satoru. Your presentation was amazing and very detailed. A lot of knowledge was put in this. I want to tell everybody that you have a button that with a little hand that you can use to raise questions. This is the great time. This is the right time to raise question. And meanwhile, you think and write your question to the panel, I would like to ask Satoru a question myself. So when you design an algorithm to create dynamic facade or paneling system, what are the constraints that you need to take into account to make it buildable? Like, for example, junction tolerance, self-intersection, drill sizes, stuff like this. What are the unexpected constraints that you had to take in account?
Usually, I mean, in the beginning, I take only a basic one, like if we can, we can for certain grid, or if it's possible to make like a certain support behind. So it's just alignment and those kind of clean alignment, or hopefully straight one, depends on the building shape. But but in the phase, we actually the constraint comes from many different aspects, and most of the time it comes from some contractor or structural engineer. So every time I hear that, and I change my design and then most of the time modifying my code or inserting new function or something. And for example, like so for example, joint system. So of course, joint should be rational, but it depends. Sometimes if you, for example, in case of a FAIA project in Morphosis, if it's the contractor labor on site is super experienced, we can trust them, and so we don't need to decide too much. So in that case, I use a universal joint, meaning I can use many different angles for joint. But if we know we don't think the tolerance is very high in the construction industry in that specific region, I design more with fixed angle. And in that case, I have to rationalize the panel or panel joint more. That's one aspect. Another thing is, another example is that constraint is that also in the FAIA Tower project, that project somehow we had to close the gap at the end because the client. So I tried to open to the maximum. The diagonal panel can open up, just maximizing the solar cutting performance. I thought it's good for giving view, but it was in the mind of clients, which actually was right. Psychologically, if you have opening area in the very closed area, your view was very distracted. You don't feel you are seeing something. It's better to close every area in 50% rather than having 100% and 20% in stripe. So we had to close. That was one constraint. Not constraint, actually, I can just close. But another problem, more practical one, was the cleaning of the facade. And then Paris it snows, so sometimes just need to clean, or sometimes need to drop snow or something. So there's a cleaning area, accessible area, but you have to clean the front side of the facade, hopefully from the catwalk. To do that, you have to have opening between them. So that's a contradiction. So we want to close for view, and we want to open for the maintenance. Also, if I open them too much, I have to have the handrail, which creates another visual obstacle. So those three come together as contradicting each other. But that comes later in the project when we notice that. But what I was trying to be ready was I tried to be ready to change my code anytime. At XML part, I have to do from scratch, but most of the time I try to organize my code to be easily separatable and stackable. So I can reuse some part of my code, but I can insert new code for the constraints. So that's how I work.
Thank you very much. That was really insightful, and again, detail, very on spot. Also, I'm impressed how you managed to bring such complex organic geometry to reality. I personally been in, so I'm Italian. I've been in Milan Expo 2015. I remember Chinese pavilion and Japanese pavilion among the best area in that exhibition. So those shapes really pay out in terms of memorability of the building, and they're worth the the effort it takes for them to be designed. But thanks to designer like you, this is possible and even affordable in certain cases. I don't see any questions, so without further ado, I will introduce the next presenter, namely Dave Alpert from GeoPogo team. I know them for, I have met them a lot of years ago. They've been around for a while. They've been building an amazing real-time AR technology for collaboration that will definitely help the next generation of architects and builders. So Dave, I'm making you a presenter. Do you prefer to start, or Mike?
To me, yeah, you're making me a presenter.
I'm going to talk.
Yeah, so
okay.
give me
All right. So here we go. You should be a presenter now.
Okay. Awesome. Okay, before I introduce myself,
one second, Dave. Sorry, Gabriele, did you make me or Dave presenter?
Dave.
No, make me, and then I'll share my screen.
Okay.
Yeah.
Okay, here we go. Sorry
there
for that.
we go. Fantastic. Thank you, Gabriele.
Okay, great technology. Thank you.
Okay, and everybody can see my screen?
Mm-hmm.
Perfect. Okay, go ahead, Dave.
Okay, well, before I start, because I just took a look at Satoru's amazing work, I just want to reflect for a moment on that kind of individual genius which creates great design, and acknowledge that we're coming at design with a different perspective. We're trying to make design more universally accessible, both for people to create and for people to understand other people's ideas. So with that as a background, I'll jump in. Okay, so as Gabriele nicely introduced me, I'm Dave Alpert, CEO of GeoPogo. GeoPogo is a 3D interactive software company that is reimagining the design and construction process. We're excited to have this opportunity to share our tools with you. We're helping people to adopt new and better ways to design for the future. Every day, we're working to democratize the design process and open up access so people can more clearly communicate their ideas and people can more clearly understand the ideas of others. So we want your open input and feedback and questions, so please fill up the chat box. I'll be presenting along with my co-founders, Michael Hoppe and Mac Dean. During our presentation, we'll hit on 3 of our key values: creativity, access, and inclusion. As an architect with 30 years of experience, both in design firms and on the owner side, my job now at GeoPogo is to bridge a chasm between the status quo of the design industry and the potential that we all have using new technology, especially AR. One of the big problems with the status quo is that the design and construction process is so messy that $1 billion a day is wasted on rework in the US alone. With the economic challenges posed by our situation today, we must do better. What if stakeholders, especially project owners, could preview and avoid rework issues that only appear as the project is built? What if? So we hit upon client-focused 3D communication as a solution. The marketplace already has 2D interactive Word and spreadsheet docs to collaborate. Now we can add easy to build and easy to view interactive 3D models to fully collaborate. After 3 years of very hard work, we now have a kick-ass all-in-one award-winning product, combining an easy-to-use design tool, an instant BIM to AR converter, and a remote 3D collaboration platform, available today. Now, although we're here this evening to focus on advanced technology, let's relax a minute and consider some of the most basic human technology, building a fire. I love to build campfires. Many people think that to build a good fire, the main thing is to throw on lots of sticks. That's what I see many people do. However, to build a good fire, the key is to leave a lot of space between the sticks for oxygen, as you see my co-founder Michael doing here. So that's how we built our crackling fire at GeoPogo. We left lots of oxygen for Michael and Mac and all the talented members of our team to be creative and inventive. So speaking of inventive, when Gabriel Sorrento was on our team several years ago, he was a co-author with me of our granted patent, 3-dimensional geospatial visualization. Look it up on Google. Before Max shares the technical wizardry with you, Michael will introduce you to our AR for Enterprise product and how customers use it. Take it away.
Thank you, Dave. Okay, everyone, hello. My name is Michael Hoppe. I'm the creative director here at GeoPogo. I'm a graduate of architecture. I graduated in 2010, and I have 10 years of experience working with architectural firms. My specialization is 3D visualization. So at the time, we did renderings, we worked in Lumion and Enscape, we did virtual reality and some real time. My work with GeoPogo is to reimagine how architecture is presented, not only to our clients, but to the public. And this is what we have created with GeoPogo. Let's begin. So what I'm going to be showing you is augmented reality on site with our AR iOS app, and I'm going to show you how to get started. So to begin with, you can start with Revit. We all use it in the industry, and it produces some very good, stable models. So here's a video here I captured of that Revit model. And typically, what your team will do is they'll model this building. Everything is good to go, except there's one key detail we just want to make sure everyone pays attention to. And that detail is when you set your materials in Revit, you're going to want to make sure, and we'll let that load for a second, it was a live capture. You're going to want to make sure that they have an image file associated with them. And this is really key, but also really good for you as designers. You'll set up your entire project model in Revit to have materials, finishes, and this will make the models really good. So to export your models into GeoPogo, you can use Lumion's free exporter. There are others, but they cost money, and GeoPogo's exporter is coming soon. So you just simply set all the settings to high, you save out that model to your project folder, and you can see here, this is ours. We work with a whole number of contractor and architectural firms daily, getting them set up on the platform. And there we go, that file is exported. So now bringing it into GeoPogo. GeoPogo comes in two parts. There's a desktop application for Windows and Mac, and there's an iOS app for iPhones and iPads. And right now we're going to start with the desktop version. So this is what happens when you open GeoPogo for desktop. you simply start and you hit import model, and you'll go ahead and locate the model that we just exported. And there it is. And we'll load that model in. Now, majority of the time in Revit, we don't always get the project coordinates set up right. We don't always use 0, 0 in Revit. So you're going to want to use GeoPogo to make sure that you set those coordinates just right. And there we go. That's pretty good. And it's very similar in nature to how we built for Lumion. Go ahead. Okay. Now, another aspect about the platform is that we built in a robust material library. That you can go ahead and apply different materials, furniture, lighting, people. You can do a lot of different things in here. And we will be implementing HD render graphics, so the desktop version will look phenomenal. Now here we've gone and we're going to export it to the app. If you don't have an account, you go ahead and create an account. And this here will pop up. We'll give that 1 second. And you go ahead and you create your email and your password, and you're good to go. You're set up on the GeoPogo platform between your desktop and between your iPhone or iPad. So you sign in, and the models can be very large. It's amazing how powerful these phones and tablets have become. They can display some very large projects. And you'll see here, I've named the project Hospital 3. You can post the project publicly, which means that anybody who has the GeoPogo app can tune in and see your project. And we do this for very large public presentations. Now it's exporting, and from there, it's going to upload, and we will see how it looks on the app. So I've gone out on site, and I've loaded the app, and I've loaded the model onto the site, and here it is. This is a recording from my iPhone, and I'm walking around, so it's a little shaky. We don't walk perfectly. And, and you can go all around the building, you can go inside the building, and you can give multiple people phones and tablets to join in on this new level of presentation with you. And these are some images that we've taken. This technology may replace rendering altogether. We as designers spend so much time modeling the existing site conditions when they're already here in the real world. And we can just simply use that instead of having to model all the buildings, all the trees, or the topography of the site. It's as best as it's ever going to be on site. So we do large public projects at GeoPogo, and this is a phenomenal technology to bring city officials, stakeholders, your clients, and the public all centered around the design that you are proposing. It's a new way to sell your designs effectively and better than ever before. So what are some of the benefits here? Why are people using GeoPogo? Well, they do it, number one, because they can eliminate design errors and you can spot site conflicts. And the biggest one all of our users have gotten is they reduce construction change orders because they're able to change things virtually. You get full client buy-in and understanding of the design vision because they're seeing it immediately in front of them. There's no more abstract, no more floor plans, sections, elevations, roof plans. It's all here. It's great for project coordination, and the on-site renderings and video walkthroughs you produce are better than anything that you'll make in Lumion or other 3D animation software. So we just finished a very large project with a large tech company down in Silicon Valley. We saved them $250,000 in construction rework by eliminating the change orders that would have driven up construction costs. And how did that happen? Because the executive teams, the facility management teams, and the end users of the client were able to see the digital overlay of the entire project, they were able to go in and start to change things immediately right there that they would have changed during construction. And when you change things during construction, you have to break up the slabs, you have to move water lines, you have to move gas lines and other utilities that drive up the costs. This client was phenomenally impressed, and they've come back for more projects. They are very happy. So I'm going to walk us through just some videos that show the potential of this technology. And again, they're all from the iPhones and some from the iPads. And you can see here, this is a model of a house that we've placed on a property. And we're able to walk through and inside the design. We're coming to a point where the graphics are going to be near photorealistic. And these walkthrough videos, you will not be able to tell if it's an actual building or if it's a rendering. You have no idea. But more importantly, the clients can actually walk through the floor plans all virtually, all on site. We did a very large project in Red Hook, Brooklyn with a visionary urban planner. This is a capture that we did 2 years ago where he sent us the model and we went out and tested this model to see how well it performed and the stability of it. And so the technology is very powerful in that it not only displayed this entire model, but you could walk around it through the entire site and you could see it through all different angles. And now we're going to go to the video that they produced for us. So in Red Hook, they flew us to Red Hook, Brooklyn. That's the visionary urban planner. And we took 2 days of guided tours, augmented reality tours through public officials, public groups, leadership. And we took them on these massive tours where the urban planner's vision was laid out in front of everybody in AR. And what is so different about this technology is that you see everything. It's not blinding like virtual reality. Augmented reality, you see all the existing conditions. You can walk around on site and you see it all. And that there in the blue jacket was the urban planner. Now this is the second last video. This is a house in San Bruno where the contractor stripped the house to the studs. We took the designer's Revit model and we overlaid it on top of the house, 1-to-1 scale. We then gave the device to the client and let them walk around their design. And this was incredibly powerful. This is just a raw Revit model overlaid. And you can see the lower and upper cabinets, the countertops, the sinks, the dishwasher, the island. And the client was able to review everything before the contractor started building. And this was an incredible presentation where they just got it. This was 10 minutes they walked around and they said, let's go, let's build this. And this is where the future of presentation is going. And we can imagine a world where the clients of Home Depot and Lowe's use this tool to imagine their kitchen or bathroom renovation or a full house redesign or addition. And I'll let this go on for a few more seconds. Again, note how stable and powerful this is. And as we work with flooring manufacturers, paint makers, and manufacturers for the doors and windows and furniture, this is a complete experience that people can have. Finally, this is a project where the architects sent the model to their clients using the GeoPogo AR app. And this is a recording of the client walking up and through the design. So here they are, they've loaded the model, they've placed it, and you can see that they're walking up to it, they're holding their phone. And I've muted the volume, but they're actively talking and giving their opinions and suggestions. And they can walk right inside, and they can go inside. The beauty is the model is as well detailed and as well finished as you make the Revit model. In this case, we did the interior very quickly, but the exterior was done perfectly. And you can see they can look through the windows and they can look back at the property. So the future of what we're pushing for design is these new interactive design mediums that really take us away from floor plans and still renderings and into a collaborative experience that everybody can participate in. And you can use GeoPogo AR on your iPhones and your iPads. We'll soon have it for Android. And with that said, I'll pass it on to our engineer, Mac Dean. Thank you, guys.
Hey, so my name is Mac Dean. I'm the technical co-founder at GeoPogo with a background in interactive media and VR AR design. AR is something new and very different to what people are used to. Thus, it can be somewhat difficult to imagine the full extent of how it can be used. But what I see as the strength of AR and VR is to merge the advantages of virtual objects with the innate human comfort of interacting in the real world. Virtual models can be edited, copied, and sent anywhere in the world within minutes, something especially important in the current climate of work from home. AR takes this further. Rather than static cardboard and plywood models or flat drawings, you can see the project as it would look finished in the real world, in its most up-to-date form. People like me outside of architecture can have trouble fully visualizing how a space will look from 2D drawings or even from still renderings. But considering we spend most of our lives inside of buildings, we have an innate familiarity with interacting with them in that way that AR can tap into, allowing untrained individuals to comprehend the architect's design as the architect envisions it. VR and AR headsets, while closer than ever, are still outside the price point or familiarity for most customers, especially considering the current perceived limited usefulness. So, we've also brought this visualization to smartphones and tablets, something near everyone has in their pockets, allowing the architect's design to be shown and understood faithfully by all. For a peek behind the scenes, at GeoPogo we repurposed technology originally meant for games, such as the Unity engine, to make both this leap to AR possible, as well as allowing real-time rendering of models. We use Unity as a middleman, importing BIM models from sources like Revit or SketchUp, where you can dress them up with new textures and then export as a new model better suited for AR visualization. It's then passed through the AWS cloud to the head-mounted displays, phones, tablets, or other users for cooperative sessions. When we applied and won the AR Technology Development Award in 2019, we were a small and scrappy team, but with a little futuristic thinking and a lot of support from our partners, we've built what I would like to think is the next step in how we communicate the design of the spaces we interact with every day. Thank you.
Fantastic. Thank you, Mac. And with that said, you can get started by downloading the GeoPogo AR app on your iPhones and iPads. And if you would like a demo, email me at mhoppe@geopogo.com. And of course, you can visit geopogo.com and you can go through all we have to offer there. We thank you, anybody, and we'll open the floor for questions.
So we got a question from Max Nyhaus again. Are you selling the viewer to be used for spaces with existing structures or only empty spaces currently? For example, rendering walls being knocked down instead of just added?
Yes. Yeah, I would say yes. So we've demonstrated here, Mike has demonstrated some where the design was inside that existing stud framework of the existing house, and some were like the hospital or the little house were being on an empty lot. And yes, you can use it to visualize what it would be like without the wall. You could see through the wall.
And Harry Richardson is asking, have you considered creating a tool for designer to be able to model in VR without a simplified interface? I'm smiling because but I'll let you, Dave, answer this question.
Well, that's you, Gabriele. I'll have to say Gabriele and his team have done a phenomenal job with Mindesk, and I highly recommend that you explore Mindesk.
Yeah. Oh, thank you very much.
No worries.
All right. Is there any other question? Yes, there is another question kicking in from Kirti Mani. Oh, that's a question for addressed to the previous speaker, Satoru. So I have a question for Satoru regarding the choice of tool for his design process. What advantage might processing have over the scripting technique in Rhino, etc.?
Yep. Okay. So, actually, when I started in 2007, for coding processing is easier, but these days processing actually Grasshopper has and Rhino has tons of options, so the gap is getting smaller. So actually you can do either, although that will be kind of up to your choice of like how to organize code, how to combine them together. When you use Grasshopper, of course it's better in Grasshopper, but some portion like agent-based optimizations, those things is still difficult to do that in Grasshopper, so that might be still better or easier in processing. So yeah, it's so that most of the time static thing, a top-down algorithm, yeah, either can work. And then for more advanced bottom-up approach, maybe more just pure coding type stuff, processing or other would be better. But I think it's all becoming all powerful and equally. It's just up to your choice or organization and preference.
Thank you very much, Satoru. I've got a question for the GeoPogo team. Oh, but first, we have another question from Max. I heard that Magic Leap is meant for indoor use. Do you have any insight into when we'll see an AR headset meant to be used for outdoors, for product exactly like yours?
Right, and that's the little trick we used in one of the videos. We ended up putting tinted lenses on the Magic Leap, and that worked perfectly for outdoor use in that case. So going back to being a scrappy team, we you know, kind of broke the system a little bit and made it work.
We hacked that one.
Yeah.
Yeah.
For context, the main issue was go for it.
Maybe Dakri has something for the outdoor as well.
Mm-hmm.
Yeah, I'd say between Magic Leap and HoloLens 2, those are your two most powerful, but both have to be modified with some type of tinted lens for it. I think one of the reasons that they want to promote indoor use, of course, is that they're not waterproof, they're susceptible to the elements. So you just have to be, cautious and intelligent how you use them as presentation tools.
Not only that, also I would say the SLAM method of keeping track of your current location works best when you have like objects in all directions. So whichever way you turn to look with the headset, it'll always have something to track. Which, if you're in an empty field and you look directly up, then your headset might lose tracking as it can't see any of the grass around you.
Exactly.
So they're trying to push people into the ideal scenario for the best possible experience for the headset. But as we go on, I fully expect for them to either include models with additional maybe rear-facing cameras, so that if you end up looking into a big void, it'll be able to continue tracking, or as Mike said, tinted lenses so that the image isn't overpowered by the sun.
Exactly.
I think we have other questions. Okay, so we have a question from Roberto Antiongene. Mark Dean, do you work with Unity or Unreal Engine for your product?
I work with Unity mostly. I've dabbled a little bit in Unreal Engine, especially for the VR development. But yeah, right now we're working in Unity.
Yeah, and it was a very calculated reasoning for that. You want the program to be able to open on any range of computers, and not somebody who only has an RTX graphics card. So if we're going to be consumer ready, it has to run on Intel graphics.
Fantastic. I got another question. So, David, do you envision GeoPogo app to be a tool for exclusively for the design process, or also a sales tool?
Oh, yes, also a sales tool. It has a lot of interest in the real estate field, and I would say it's also a construction tool because it serves as a reference point all during construction. At any point in any place, you can pull up in full scale overlay the design.
Yeah, and especially once geolocation becomes prominent, the model will technically be stationed forever. And so you just open up your phone when you're on site, and the model's just always there. And this is
and we can go one stage further, in fact. After the project is occupied, as long as what's concealed behind the floors and the walls and the ceilings has been accurately recorded into the Revit models, then you can use the AR model as X-ray vision. You can see exactly what's behind all the surfaces.
Yeah.
There is another question. So, do your scene remain geodesically anchored? How do you achieve that?
Yeah. So Mac can do that one. What we've always done is we basically, to start, you place the model on the site, and you may have some particular site markers. And what you do is you align the building with those site markers. In the future, when we get geolocation down, where you just simply drop the model on some Google Map-esque type map, then everything will be perfect within, say, a few inches, and then you can just manually adjust. But for right now, you place the model, move it with your fingers, rotate it, and then lock it in place.
I've heard about companies like Microsoft with the Azure Anchor and 6D.ai solving this very problem, and Niantic as well. So soon it will be there, I would suspect.
Yes.
Indeed.
There is wow, so many questions today. Christopher Rojas is asking, what are the next steps for GeoPogo? How are you considering creating interaction in AR to allow annotation that could be captured and stored for review later?
Yes, that's actually one of the things we're working on right now is stored annotation. I mentioned collaboration. Right now, we're sort of building out a multi-user suite so that off of the desktop program, you are able to have multiple people in the same model at the same time, and you can sort of give virtual guided tours of it. And we're looking to, in the future, roll that out to the mobile and head-mounted displays as well. As Mike mentioned, especially with the AR, being able to have multiple layers of precision, both geolocation to get you on site, then maybe markers like what with Azure and Microsoft are doing to get you really precise, and then maybe as a fallback, manual control to adjust should your device lose a little bit of tracking.
Sorry.
Go ahead.
Okay. Our plan, in addition to these annotations that is that those annotations will be rolled up into a spreadsheet type document so that they can be tracked. Because it's one thing to mark up a drawing or a model, but it's another thing to be able to track it. And this can feed into existing PM systems.
There is another question from Roberto to Satoru. Do you work just with the Rhino Grasshopper or also with Revit Dynamo? Any VR, AR tools in your company?
In my case, I work with processing 95%, and then Grasshopper just as a support, and then AR, VR. No, I haven't actually. VR, I worked on some time, not for design project, but just to build a show. Just different project. Like I built like a web configurator for construction material company. just to play with like a 3D model on website and then choose the different shape, etc. But usually in the architecture design project, I don't use that. So yeah, ALVR, I see tons of like people in academia start using like, all the kind of advanced construction, and that's maybe I haven't. I'm kind of staying the algorithmic side, so I haven't touched it yet.
Thank you very much. All right. I think there are no other questions left. So I think we can wrap up this session. Jennifer, do you want to give a few closing words, maybe?
Sure. Thank you guys for spending your time with us. And that's it.
All right.
Very good presentation. Thank you.
Thanks everybody. Thanks the guests for the amazing presentation and the very valuable insights in new technologies. Thanks to our sponsors, and let's meet in a month on July 17th for the next presentation.
Okay, thank you too, Gabriele.
Thank you, Gabriele.
Thank you.
Thank you.
Bye-bye.